Hello there, Mr. Sutton here with the IM3 Honors 1-1 Extra Practice Part 1 Solutions on Domain, Range, and Functions. For this problem, we're trying to find domain and range and whether this thing's a function. So for domain, that is all the x values that our graph is covering. We see here that we're going as far left as -3, and the function actually exists there. So that's going to be a square bracket on -3. And then over to the far right, this branch of the function ends at 4, but this other branch goes a little further all the way to 5, and we have an open dot there to hold the place, but the function doesn't actually exist at 5. So that's going to be a rounded parentheses on 5. So we have bracket -3, comma, 5 parentheses. That's for the domain. Now for the range, we're going from, this is for the y values here, we're going as low as -4 with an open dot, and as high up as +3 with a closed dot. So we're going to have a parentheses for -4 and a closed dot, or a bracket for +3. And then for the function, whether or not it's a function, we just look at the vertical line test to see if we can draw a vertical line that crosses this more than once. And we see there are lots of places we can draw vertical lines that touch the function in more than one place. So this is not actually a function. I said function, it's not a function. So for example, we can draw a vertical line right here that touches in 2 places. So definitely not a function. For this one, we want to first figure out the domain and range of this graph. So for domain, that's the x values. On the far left, we've got -2. On the far right, we've got +3, and this graph goes continuously from one end to the other. So we're going to do since we have a solid dot, we're going to do a bracket for -2, and 3 we've got a solid dot as well, so another bracket. So then -2, 3, both with brackets for domain. For range, we're looking at the y values from bottom to top. So at the bottom, we've got -4, solid dot gives us a bracket. And at the top, we have +4, solid dot gives us another bracket. Now, for whether or not this is a function, since we cannot draw a vertical line that touches twice in any place on this graph, we say that yes, this does pass the vertical line test. This is a function. And since it's a function, we're going to talk about where this is increasing, decreasing, or constant. Now, this graph is going down everywhere from -2 to +3 over its whole length here. So for decreasing, we're going to say -2, 3, and we're going to use parentheses for that. We always do for increasing, decreasing. And now for increasing, well, it's not increasing anywhere. So that's as good as this one's going to get. For this problem, to figure out the domain of this graph, we're asking about the x values from left to right. So on the left, we have -2. On the right, we have +5. We have open dots at both of those. So those are both going to be parentheses, -2, 5. And there's no breaks in between, so it's just one interval from -2 to 5 for the domain. For the range, that's the y values from lowest to highest. And we see that we have a continuous function in terms of y values between the endpoints. Now, on the lower end, we have a y value of 0 down here at this open dot. On the upper end, we have y value of 2. Now, although there is an open dot here, we see that there's a solid line that takes up the rest of the function's place here at y equals 2. So we do actually have y values of 2 existing for this function because of this solid line. So that means we're going to have a parentheses on 0 at the beginning, but then we're going to do (2) with a bracket because this solid line is telling us the function exists up there. And I've been using the word function, but is this actually a function? Well, can we draw a vertical line that touches twice anywhere, the vertical line test? We cannot. If you move a vertical line across here, you're touching only once all across this graph here. So this is a function then. It passes the vertical line test. Now for increasing, decreasing, or constant intervals, we see that we're actually increasing, going up between -2 and 0 for the x values here. So we have an increasing interval from -2 to 0. And then there are no decreasing intervals, but we do have this constant flat line interval from 0 to 5. So we'll write 0, 5, all of these with parentheses. For this problem, we want to know the domain and range first off of this graph. For domains, we're talking x values from left to right. Now we see that on the left, we're actually going left forever because of this arrow here. So we have a left value of negative infinity, if that could be said to be a value, and that's always going to have a parentheses. On the right, we have 0 and an open dot at 0. So we're going to have parentheses on that one as well. So we're going to have parentheses, negative infinity, comma, 0 parentheses for domain. Now for range, for the y values going from lowest to highest, on the lower end, we have a negative infinity because we're going down forever here. And then on the upper end, we have positive 4, open dot at 4. So we're going to do parentheses for both of them, negative infinity, comma 4 for the range. As to whether this is a function, we see that if we try drawing a vertical line that touches twice on this graph, we're not going to be able to do it. It only touches once everywhere from left to right. So that means that this is a function. Every input gives you only one output. And finally, for increasing, decreasing, and constant, along the whole interval where this function exists, we are going up and to the right. So that means that we are increasing everywhere this function exists. So we're going to be increasing along the domain here from negative infinity to 0. And then we don't have any constant or decreasing intervals anywhere, so we're done with this one. For this problem, for the domain, we're asking about x values from left to right. So it looks like we're going to the left forever because of this arrow. Same thing with to the right. Now, although this is a very steep slope, we are actually moving right forever. If you go down far enough, you can get any x value you want to either the far right or the far left. So we're going to go from negative infinity to positive infinity for the domain, and we're going to need parentheses on that because we always need those on infinity, because you can never actually include infinity in your interval. It's not actually a number. Now for the range, for the y values, we're going from lowest to highest. So we're going down forever over here. Up here we're going up forever, and there's no breaks in between. So our range is going to be from negative infinity to positive infinity as well. And this is, again, y values we're talking about. Still using parentheses, though, because you can't actually equal infinity. Now, for whether or not this is a function, if we try to draw a vertical line that touches twice anywhere, we won't be able to do it. Every vertical line we draw through this graph is going to touch only once. Although we have a very steep slope, it's still only going to touch it once if you really zoom in far enough. So this is a function then. And for increasing, decreasing intervals, first the increasing, our function is going up from negative 3 to negative 1. So, and that's always parentheses for these. So we'll say increasing, negative 3, negative 1 with parentheses. Now for decreasing, we're going down from negative infinity out here to the x value negative 3. So we can say negative infinity, comma, negative 3 with parentheses. But that's not the only place where we're decreasing. After we stop going up here at negative 1, we're going back down again. So from negative 1 to positive infinity, because you can keep going right here, that would be our other decreasing interval. And we'll use a little union symbol to link that in and show that it's part of this answer. For this graph, the domain, the x values going from left to right, we've got negative infinity as we go to the left because we can keep going. Positive infinity as we move to the right because, again, this arrow tells us we keep going. And no breaks in between. So this is a domain of parentheses, negative infinity, comma, positive infinity. And we need parentheses because you can't equal infinity. Now for the range, the y values, the lowest we can go here, it looks like our graph is approaching but never quite getting to the y value 0, to the x-axis. So we'll have an open parentheses, a rounded parentheses on 0. Now as we go up here, we can't get any higher than 5, the y value 5, and it looks like we can equal 5. So we'll have a bracket on 5. So parentheses 0, comma 5 bracket. And now for the function, everywhere you draw a vertical line along here using our vertical line test, you're going to see that we're only hitting this graph one time with every vertical line. not twice. So that means that this is a function that they gave us here. For decreasing and increasing intervals and all that, it looks like we are increasing over here on the left side from negative infinity to 0. We're going up over that whole stretch, although going up very slowly as you look further and further to the left here. So we'll have negative infinity, comma 0 with parentheses for the increasing interval. Now for the decreasing interval, after we get to 0, we start going down, and we're going down forever. Even though we never actually get to 0, we are decreasing at a slower and slower rate, but still decreasing. So we're going to say from 0 to positive infinity for the decreasing interval. For this one, to figure out the domain, we're trying to figure out the x values where the function exists. So it looks like our function goes to the far left, so negative infinity, and it also goes to the far right forever with this arrow, so positive infinity. But we do have this spot, this vertical asymptote in between where the function does not exist. So we're going to have to leave that out of our interval. So I'll have one interval with parentheses everywhere from negative infinity to positive 2. And I need the parentheses on negative infinity because we can't actually equal infinity. I need it on 2 instead of a bracket because although we are approaching the x value 2, we're never quite getting there because of this vertical asymptote. Now we also have a branch of the function from almost 2, so we'll say parentheses 2 to positive infinity, representing where our function resides. And we'll have a little union in between those two intervals so that we know that this is all part of the same answer. Now for the range, that's the y values going from lowest to highest. So on the bottom end, we can go all the way to negative infinity, or at least we approach negative infinity. We're going down forever. But as you move further up here, you'll notice that we don't get past negative 4. We stop at negative 4, and then there's a gap. So I'm actually going to have to split this up into two branches for range, just like I did for domain. I can say parentheses negative infinity, comma negative 4, and I'll need a bracket on negative 4 because the function does actually exist at the y value negative 4. We have a solid line there. Now our function picks back up at 0 on the x-axis here, and then we're going up forever as we move higher up. So we can say bracket 0, comma, positive infinity with a parentheses, and we'll use the union to group those together as well. Now for whether this is a function, if I try drawing a vertical line that touches twice, I'm not going to be able to do it. Everywhere you draw a vertical line, you are touching only one branch of the function, and you're touching it in only one place from left to right. So that means this is a function. Now for increasing intervals, let's see here. We start off decreasing, going down, but then once we get to 0 for the x values, we start increasing. And we're increasing, the function doesn't actually ever equal 2, so we can't include 2 in the interval. But we can at least say 0, comma 2 with parentheses. But now the function is also increasing after that vertical asymptote right down here. So we're also going from 2 to, it looks like 4 here for the other increasing interval with a little union in there to keep those together. Now for decreasing, we start off decreasing, and so that means negative infinity, comma, until we get to 0 here. And then we have this other decreasing interval starting at 4 and going to positive infinity as well that we can union in there. On this one, to find the domain, the x values where this function exists, we're going from left to right. So on the left we have 0, the x value 0 on the y-axis. And as we move to the right, we see that to the endpoint here, there's no breaks in between, but we get to this endpoint at positive 4, and there's an open dot there. So we're going to need a bracket on 0 and then a parentheses on 4 to represent where the function exists and where it doesn't. So bracket 0, comma 4 parentheses. Now for the range from lowest to highest for the y values, down below here we've got negative 4 for the y value, and as we move up here, the highest we get is 2. And the function exists, or the graph, I should say, exists everywhere in between those y values. We do have an open dot here at the y value 0, but there's also a solid line, so that takes priority over the open dot and makes us include 0 in our range. So I can go from bracket -4 to bracket +2 for the range. As to whether this is a function, we can draw a vertical line that touches twice, more than twice actually, right around here. So we would say, no, this is not a function. And here's that vertical line you can draw to kind of show that this is not a function. We have the same input, any of these x values here, giving you multiple y values in return. Since this is not a function, we don't have to worry about increasing, decreasing, or constant, because those only really apply to functions.